Hello and welcome back to the Math Mindset. Today we'll be continuing our Factoring Quadratics series with part 2. I know it's been a long while since I've uploaded, but here's the video. So just as a refresher, the standard form of a quadratic is ax squared plus bx plus c. Now when we're looking at factoring quadratics, we can split this into two cases. So let's look at the first case. The first case is when a is equal to 1. When a is 1, the quadratic will look like x squared plus bx plus c is 0 when you're factoring to find solutions. Right, and when it's like that, there are a few neat tricks you can use, and it's less complicated to factor quadratics like that. So let's look at how we can do that. So step 1, find two numbers that add to b and multiply to c, right? So we'll call those numbers q and r for future reference. So once you find those numbers, you can write the quadratic x squared plus bx plus c as x plus q times x plus r, right? So it's x plus q, not x minus q, and it's x plus r. So you can write it like that. And like I said before, q and r are the numbers we found in step 1. So let's practice with an example. So I'm going to take a look at the quadratic x squared plus 3x plus 2. And we have to factor this. Now, using the two steps that we discussed above, we want a couple of things. We want two numbers that add to our b value, right? Add to 3 in this case, which is our b value, right? And we want them to multiply to 2, our c value. So what are those two numbers? Well, those two numbers are 2 and 1. Okay, so we can write this quadratic according to step 2 as x plus 2 times x plus 1, where 2 and 1 are the numbers we found. Now to double check, we can multiply this factored form out. So let's check. Right? Let's check. So x plus 2 times x plus 1. So this is x squared plus x plus 2x plus 2. We used FOIL here. And when we combine like terms, we get x squared plus 3x plus 2, which matches the quadratic we were given. Let's look at another example like this before we move on. So let's look at another quadratic. I'm going to say we have something like x squared plus 8x plus 16, right? And we want to factor it. So we want to find two numbers that add to 8, right? We want them to add to 8, which is our b value, and multiply to 16, which is our c value. So what are those two numbers? Well, if you run through the possibilities, you find that 4 and 4 are our numbers. And it's perfectly okay to have duplicates like this. right? This just means you have one solution that appears twice. You can have duplicates. So when we write it in factored form, x squared plus 8x plus 16 is equal to x plus 4 times x plus 4, or x plus 4 whole squared. And if you multiply the factored binomial on the right out, you will get that it equals x squared plus 8x plus 16. Now, moving on to case 2, right? Case 2. A is not equal to 1, right? So what do we have? If A is not equal to 1, we're left with the standard form ax squared plus bx plus c. Now, we have to use what's known as the AC method, right? So the first step of the AC method is find two numbers that add to B and multiply to A times C. It's not C this time, it's A times C, right? And then we do factor by grouping, right? Split ax squared plus bx plus c as ax squared plus qx plus rx plus c. Remember we said q and r would be the two numbers that we'd find for future reference. Let me underline this. This is really important. And now you'd factor by grouping. Factor by grouping, which would look something like this, right? You have ax squared plus qx plus rx plus c, right? You would split the quadratic. I mean, you would factor the expressions in parentheses. So let's look at an example to understand how that works, right? So I'm gonna look at what would be a good one to use? Let's say I have 2x squared plus 9x plus 10, right? And we want to factor this. Now, how would we go about doing that? Well, using the AC method, let's circle our A value and our C value and underline our B value. So we want two numbers that add to 9, which is our B value, so that's B, and multiply to 2 times 10, or A times C, which is 20. So what would those two numbers be? Well, 20 is 1 times 20, 2 times 10, 4 times 5. 4 plus 5 is 9, but 4 times 5 is 20. So we can just use it. So we can use 4 and 5. So then we'd split the quadratic as follows. 2x squared plus 4x, which is one of the numbers we found, plus 5, which is one of the numbers we found, x, plus 10. Split the quadratic in half and factor by grouping, or factor the terms in parentheses separately. So if you factor this, according to part 1 of the video, we can take out a 2 and we can take out an x, leaving us with x plus 2 on the inside. And then 5, we can take out for the second set, and we have x plus 2. Aha! The terms in parentheses below are the same. So we can combine the 2x and the 5 like this. So we can write it as 2x plus 5 times x plus 2. Right? The circle terms came together because the x plus 2 were identical factors that were pulled out in the split quadratic. Let's try another example. Let's try one with negatives this time. Let's say we have 5x squared plus 4x minus 12. Right. Now, we need two numbers that add to 4, right? Because that's our b value, and multiply to 5 times negative 12. Which is negative 60. So what two values multiply to negative 60 but add to 4? Well, those values would be 10 and negative 6, right? So we found our values. So 10 and negative 6 are our values for this example. So we can split the quadratic like this: 5x squared plus 10x. Usually you want to group like the split terms. So 10x and negative 6x, these are the terms that we branched out from 4x. We split 4x into those two terms. Usually you want to group those terms with terms that have a common factor in their coefficients. So like here, 5 and 10 have a common factor. If I did negative 6x plus 10x, that would make no sense because negative 6 and 5 don't share any factors. So you want to split it and write it the right way so that factor by grouping works out. And in case it doesn't work out, all you have to do is switch the order of the split terms and it should work. So with that said, let's move on. And we'll add our minus 12, right? Now, whenever you can factor negatives out, just do it, right? And we'll see that with this example. By factor by grouping, we'll split these quadratic. So this is an imaginary plus right here. Include all negative signs of terms when you're splitting quadratics. So in this half, we can take out a 5x, leave with x plus 2. And in this half, we can take out a negative and a 6. So we can take out a negative 6 and leave us with x plus 2. Now once again, x plus 2 is common to both sides. So we can combine 5x and negative 6 like this. 5x minus 6 and x plus 2 is equal to 5x squared plus 4x minus 12. And if you multiply it out and check your work, you will find that this is the correct answer. Right? And I want to end this video by discussing one more case, right? Case 3. A is negative, or A is less than 0. Well, if A is less than 0, then what you should do, multiply your quadratic by -1, right? Quadratic by -1. Factor that quadratic, right, according to the steps we discussed in case 2. And then add a negative sign in front of the quadratic, in front of the factored quadratic. Factored quadratic. Right? You don't have to do this. You can still follow AC method for quadratics with negative leading coefficients. But according to my opinion, this will make your life easier. This will make your life easier when you're factoring quadratics that have negative leading coefficients, because it's much more intuitive to factor positive quadratics or quadratics with positive leading coefficients than it is to factor quadratics with negative leading coefficients. And with that marks the end of this video. Don't forget to share this video with those you might find it useful and those who might need it. Maybe people in your class might need this video. And don't forget to leave your thoughts and other suggestions down below. And I'll see you in the next video. Goodbye. In the meantime, check out this video, or if you have the time, check out that playlist. But don't forget to subscribe.